Hello everybody. This is your practice problems video for the Pythagorean theorem and using its converse. So let's go ahead and jump into it here, right? So this first set of problems here is just the regular Pythagorean theorem and using that to find a missing value, okay? So for part A right here, I'm actually not going to solve this with the Pythagorean theorem because I know that this is a Pythagorean triple. Hold on. It was terribly written by me. Let's try that again. Okay, so if you recall from the notes video on Pythagorean theorem that there are some special sets of numbers that are all whole numbers that work in the Pythagorean theorem. And this is the most common one, right? It's the Pythagorean triple 3, 4, 5. So 3, 4, which means x is 5. Okay? But you could go through and solve that and figure it out in the actual Pythagorean theorem using the Pythagorean theorem as well, right? Okay, so let's look at B. So with this one, I'm trying to find this value right here, which is going to be my A. This value here, 11, will be my B, and obviously 18 is my C. It's my hypotenuse. I can tell because it's always across or opposite the 90-degree angle. Okay, so what I have here is y squared plus 11 squared equals 18 squared. Okay, and then after that, I basically just have to use my knowledge of exponents and my algebra skills in order to figure out what y is. So I have y squared plus 11 squared is 121 equals, and then you have 18 squared, which is 324. Then I'm going to subtract 121 from both sides. So I get y squared is equal to 203. And then my last step is to take the square root of both sides. Obviously, 203 is not a perfect square number, so you're not going to get a whole number, which is totally fine. Okay, so this value in decimal form is 14.25. I'm going to say if I round up. Right? So this one, part C, is very, very similar to this problem, B. So I want you to pause the video, give that third one, C, a try, and see if you can solve for X. All right, folks, so go ahead and check your answer against mine. I got X equals 40.19 when I rounded, plugged everything in, and solved for X there. So my formula, or plugging everything into the Pythagorean theorem, was 33 squared plus X squared equals 52 squared. You could have switched the 33 and the X. It doesn't really matter which leg you say is A and which one you say is B. The most important thing is that the hypotenuse, the longest side, the one opposite the 90-degree angle, is always C over here by itself. Okay? All right, so let's take a look at some converse problems now. Okay, and I'm actually not going to do part A because I use the exact same set of numbers in the notes video. So that would just be me like repeating a problem. Okay, but I will definitely show you this one, B here, and then I'll have you try C on your own. All right, so let's give this a try here. Okay, so remember, we are trying to figure out what type of triangle we're dealing with. Okay, but first I have to check to see if this set of numbers, this set of side lengths, actually forms a triangle at all. So remember, what you do is you add the two smaller numbers and see if it's greater than the largest number, which it is not in this case, right? So once a triangle doesn't pass the triangle test, you stop right there and just say that this is not a triangle. And that's all you have to do for this one, right? For part C, right, this one does pass the triangle check, right? 9 plus 9 is 18, which is greater than 13. So I can say check, that's what I want. So now I can plug these values into the Pythagorean theorem and see what happens. Remember, the longest side is C, and because this is a converse problem, I'm going to list that first, right? Just because it makes it a little bit easier for me to figure out what's going on with the relationship between the numbers on either side of the relationship sign, whether it's an equal sign, a greater than symbol, or a less than symbol. Okay, so I have 13 squared. I'm going to put a little box right there because I don't know what goes in it yet. And then I have 9 squared plus 9 squared. Okay, so 13 squared is 169. 9 squared is 81. So I have 81 plus 81. So I have 169. I have my box, and then 81 plus 81 is 162. So what goes in this box is a greater than symbol, right? Because 169 is greater than 162. Because that is true, this is an obtuse triangle. Okay? All right, so I'm going to do one more example for you using pictures instead of just listed side lengths, right? Which is what this problem is here. Okay, all of these sets of numbers do form a triangle. You already have the picture, so you don't really have to do the triangle check here. So what we're going to do is throw these right into the Pythagorean theorem. Okay, so most important thing for me to identify is the longest side, which is, in this case, this one, 97. Right? So that's my C value. So I have 97 squared. I'm going to put a box because I'm not exactly sure what goes there yet. And then I have 65 squared plus 72 squared. Okay, those numbers are pretty large, so I would pull out a calculator to do multiplication or exponents that large. So I'm going to do 97 squared, which is 9409. And my little box. 65 squared is 4,225. And then 72 squared is 5,184. Right, so then I need to add my values on the right-hand side. So I have 9409. I have my little box. And then if I add these two values together, I get the exact same thing, 9409. So these are equal, which means this is a right triangle. Okay, all right. So I will tell you that of the 3 that are left here, there is 1 more right triangle and 2 that are not right triangles. So what I want you to do now is pause the video and give these 3 problems a try on your own, and then come back and check with me and we'll see how you did. All right, folks, so go ahead and check your answers against mine. So for part B, or for question B on this one, I got that this was an obtuse triangle. So my C value was 42. And then my other 2 values, A and B, were 9 and 40. Plug them into the Pythagorean theorem, and I got that at the end, 1764 was greater than 1681, so obtuse triangle. Part C was another right triangle. Even though the numbers were really large, you still end up with a right triangle here. So my largest number here was 125, so that's my C value, goes on the left-hand side. I have my little box, and then I have 44 and 117 are my other sides. Square everything, add what needs to be added, and you end up with the same 2 numbers on both sides, so that has to be a right triangle. And then for the last one, I ended up with an acute triangle. 58 was the longest side length, so that's C. Then I have A and B, 40 and 45. Square all of those numbers, add the squares of 40 and 45, and what I ended up with was that the square of 58 was actually less than the sum of the squares of the other 2. 3,364 is less than 3,625. So that means since the hypotenuse value gives you a less than, then you have an acute triangle. Okay, the key thing to remember with converse of the Pythagorean theorem especially is it's all about what the relationship is with the squared hypotenuse, right? The longest side is the most important. If it's equal, it's a right triangle. If that particular side is the greater side when you plug it into the converse Pythagorean theorem, it's an obtuse triangle. Less than, it's an acute triangle. All right, you guys, I will see you in the next video. I hope you found this one helpful. See you later. Bye, everybody.